Hello, students. Very good afternoon. I welcome you all. Your chemistry tutor, Mayur S. More. This is our chemistry, JEE chemistry, session number 2 for structure of atom. As you all know, we have started the chapter called structure of atom in last session, where we have covered the discovery of protons, neutrons, electrons, how their charge were found, how their charge to mass ratio were found. Okay, now today we're gonna take that to forward. Okay, so very good afternoon, everyone. This is Maviresh More. Welcome you all on a practically live. Okay, so let's begin. So, atomic weight. So, look, there are some species which might have two or three different atomic weights. Now, you might say, sir, how could that is possible? See, that is possible when you are having isotopes. Whenever you are having isotopes, it is possible for species to have two or three different atomic weights. Okay? And in that case, the atomic weight of an element is the average weight of the isotopes of that element. For example, suppose if there is an element which have three isotopes, y1, y2, y3, and their isotopic weights are suppose w1, w2, w3, and their percentage, I would say possibility or probability or ratio of occurrence in nature are x1, x2, x3 respectively. Then their average atomic weight of those elements would be like this: y1 into x1 plus y2 into x2 plus y3 into x3 divided by x1 plus x2 plus x3. And we all know the percentage of all the is equal to 100. So this will give you the average atomic weight of those elements. Okay, that's the formula. You will understand this more easily when we will cover the numerical based on. Okay, let's see the numerical based on this. An element have three isotopes, and their isotopic weights are 11, 12, 13 unit. Okay, and their percentage occurrence in nature, are 85, 10, and 5 respectively. Oh, I'm sorry. The percentage occurrence in nature is 85, 10, and 5 respectively. Then calculate the average atomic weight of the element. So how can we calculate? As per our formula. What was our formula? Average atomic weight. Average atomic weight is equal to isotopic weight and its percentage. Now, since they have given this in a what respectively manner, so 11 atomic weight having percentage how much? 85, right? Ah, अरे यार, sorry. 12 atomic weight, it having 10 percentage, and 13 atomic weight is having a 5 percentage. Divided by what? Divided by 85 plus oh, I'm sorry. Divided by 85 plus 10 plus 5, which is obviously equal to 100, right? So 85 into 100. Oh, I'm sorry, I might have got a cold. 85 into 11. 11 5s are 55. You got 5, 5. 11 8s are 88. 88 plus 5, 93. Right? So you got 935 here. 12 into 10 is how much? 120. Right? 13 into 5 is how much? 65 divided by 100. Right? So 935 plus 120 plus 65 is equal to 5 plus 5, 10, 0, 1. 3 plus 1, 4. 4 plus 2, 6. 9 plus 1, 10. 1060. 1060 divided by 100. 0, 0 gets cancelled. 106 divided by 10 is equal to 10.6. So 10.6 is its average atomic weight. That is how you can calculate the average atomic weights. Okay, that's the formula. That is the way of solving it. Okay, chalo. Moving ahead with this. Next, here average atomic weight is given. Average atomic weight of an element is given. It is 51.7. Okay, now if two isotopes M50, N52 are present, then calculate the percentage of occurrence of M50 in nature. Now we don't know it is, right? Then we calculate the percentage. Suppose percentage of M50 is X%, right? Now you know that percentage of M50 plus percentage of M52 has to be 100, right? Because those are the only two isotopes they are saying for M, right? So if for M50 it is X, then for percentage of M52 has to be how much? 100 minus X. Right? For percentage of M52, it has to be 100 minus X. Oh, sorry. So, then percentage of M52 is equal to how can we calculate? What was our formula? Average atomic weight was equal to M50, right? M50 for how much it is? We don't know it. It is 50, right? 50 into X%. Now, for M52, it is 52, right? 52 into 100 minus X. It is M52 100 minus X, right? Divided by 100. Now, what is the average atomic weight? It is 51.7, right? So, 51.7 is equal to 50x plus this will multiply this 5200, sorry, yeah, 5200 minus 52x divided by 100. Sending 100 to that side, what would you get? 5170 is equal to 50x minus 52x plus 5200. So 5170 sending 5200 that side. 50x minus 52x is equal to minus 2x, and 5170 minus 5200 is equal to what? Minus 30. Minus 2x, minus minus gets cancelled. Therefore, x is equal to 15%. So x is 15%. That means M50 is 15%. They are asking about M50 only. You can calculate for M50 also. M50 is how much? 100 minus x, right? And how much is your x? Your x is 15, right? So it becomes 100 minus 15 is equal to 85%. So 85% for M52 and 15% for M50. So that is how, if the average atomic weight is given, you can calculate the percentage of isotopes in that given element. Okay, so moving ahead. Now we'll see what are isotopes. Okay, isotopes. See, they are the atoms of a given element which have the same atomic number. Isotopes are the atoms of a same element. They are atoms of the same element having same atomic number but different mass number. Their mass number is completely different, and that means they have same nuclear charge, because nuclear charge is given by what? It is given by protons only. And since the atomic number is same, the number of protons are also same. If the number of protons are same, the nuclear charge is also same, but they have a different number of neutrons. As we all know, how do we represent a species? X, Z, A. This is your atomic number, right? And what is your A? A is your mass number. So atomic number is same, but mass number is different. If the mass number is different, that means A minus Z should also be different, right? So that is how the isotopes are. So look at this example. These are the isotopes of chlorine. Chlorine 17, chlorine 17. So number of protons are same. How many protons they have? 17. 7. And 35 is what? 35 is here mass number A. So if you count their A minus Z for this species is how much? 35 minus 17, it's 18. 18 is number of neutrons. If you look at here, it has 18 neutrons, it has 20 neutrons. Number of protons is also same, so therefore number of electron would also be same. You can see here. Both of these are similar. Number of protons and number of electrons are exactly same, but the number of neutrons has to be different. Why? Because mass number is different, no? So if the mass number is different, the number of neutrons has to be different. They are not equal. Okay? These are called as isotopes. Let me give you some other examples also. Carbon. 6, 6, 6. Mass number 12, 13, 14. If you calculate the number of neutrons, protons for them, how many protons do they have? 6, 6, 6. How many electrons do they have? 6, 6, 6. How many neutrons do they have? 12 minus 6, 13 minus 6, 7. 14 minus 6, 8. So you can see here number of neutrons are different. So these are the isotopes of carbon. Let's look at the isotopes of hydrogen. H. Okay. All of them are having atomic number again 1, 1, 1. Mass number are 1, 2, 3. Protons 1, 1, 1. Electrons 1, 1, 1. What about the neutrons? 1 minus 1, 0. 2 minus 1, 1. 3 minus 1, 2. So again, number of neutrons is different. Everything other than that is exactly same. And such species are called as isotopes. This H2 is also called as deuterium. This is also called as tritium. Okay, then you also have isotopes for oxygen. 8, 8, 8, 16, 17, 18. Again, number of proton is what? 8, 8, 8. Electron again is 8, 8, 8. Number of neutrons, 16 minus 8, 8. 17 minus 8, 9. 18 minus 8, 10. See, number of neutrons are again different. That is how the different isotopic species are, where number of protons and number of electrons are exactly same, but the number of neutrons are always different. Okay, so moving ahead. See, let me tell you one more point. As I told you already that isotopes have same number of protons and they also have same number of electrons, and chemical properties chemical properties are dependent on chemical properties are dependent on number of protons and number of electrons. Chemical property is dependent on number of protons and electrons. Since the isotope has the same number of protons and same number of electrons, their chemical properties are exactly same. They have a same chemical property. But physical properties would be different. That is obviously because physical properties are decided by mass. And as you had seen, the mass of isotopic species are different. So if the mass is different, since the physical properties are derived from the mass, if the mass is different, physical properties are bound to be different. Okay. So isotopes do not have same value of E by M. What is E by M? Number of mass of number of electron to mass. So number of electrons is same. See, E by M ratio. E means what? Number of electrons. Okay. Number of electrons remains same for isotopes. But mass, M is mass. And as I told you, mass is differing. So if the mass differs, even if the numerator remains same, but denominator is changing, because of which the whole E by M ratio changes. Okay, because the mass is varying. So number of electrons are same, but mass varies. Okay, that is what the isotopes are all about. Okay, so now moving ahead, if you have any doubt with whatever I have taught you just now, you can ask me in the comment section. Okay, so now moving ahead, what are isobars? See, they are the atoms of a different element. Now, they are the atoms of complete different element which have the same mass number. Which have the same mass number but different atomic number. Now mass number are same but yeah. uh, I'm extremely sorry. If you look at the last case, where what were the isotopes? Where the mass number was different, but atomic number was same. In this case, mass number is same, but atomic number is different. And such a species are called as isobar. Okay. Yeah. Sorry. Now look, if the mass number is same but atomic number is different, that means yeah, if the atomic number is different, it is obvious that they will have a different number of protons. If they have a different number of protons, obviously they will have a different number of electron also. Yeah. They will obviously have a different number of electron also, proton also. and it may be neutron. We need to check that. Okay, but number of nucleons is same. What is mean by number of nucleon? Nucleon means number of protons plus number of neutrons. So if the number of protons per neutron is same, the nucleon number has to be same. Let me give you an example. You would understand it. Take this example. Carbon 6, atomic number 6, mass number 14. Nitrogen 7, mass number. Now you can look at clearly here. How many protons do they have? 6. 7. How many electrons do they have? 6, 7. See, both are different. How many neutrons do they have? 14 minus 6, 8. 14 minus 7. See, everything is different. Between them, everything is different. Number of protons are different. Number of electrons are different. Number of neutrons are different. But proton plus neutron, this sum, which is also called as nucleons, is same, because this number of nucleons is nothing but what? A. And A is what? Mass number. And that I have already told you that they have the same mass number, no? Mass number is same. But that doesn't mean that protons and neutron numbers are same, because 7 plus 7 is also 14 and 8 plus 6 is also 14. Okay, sure. Now, as I told you here, since they have everything different, number of protons is different, number of electrons is different, so chemical properties has to be different, right? Their chemical properties are surely different, but physical property they will have same because their mass is same. Okay, see, isobars do not have same chemical and physical properties. Now, in some way, physical properties are same, but chemical properties cannot be same because they are belonging to completely different element altogether. Okay, they also do not have same value of E by M. The value of E by M is also different. Okay, so moving ahead, look at this example. I told you there one example. These are also isobars. Look at here, number of protons, how many? Number of electrons are 19. Number of neutrons are 40 minus 19, 21, right? Then number of neutrons, 40 minus 20, how many? 20. See, everything is different. So that is how your isobars are. Okay. So that's it for the isobars. Moving ahead. Isodivers. What are isodivers? Isodivers are, they are the atoms of a different element. They are the atoms of different element which have the same difference of number of neutrons and protons. That means they are completely different atoms. They are completely atoms of different element, but the difference between the neutrons and protons is exactly same. Look at here. Your boron has how many protons? 5. How many protons? Carbon 6. Electrons 5. Electron 6. Number of neutron 11 minus 5, 6. Number of neutron 13 minus 6, 7. Now they are saying the difference between what? Number of neutrons and proton. That means N minus P. Now look at the N minus P for the boron. How many neutrons are there? 6. Protons are 6 minus 5, 1. So N minus P is 1 for your boron. For carbon, look at the carbon, N minus P. How many neutrons are there? 7. How many protons are there? 6. 7 minus 6, 1. So N minus P is equal to 1 for both these species. And such a species are called as isodivers. Okay. You can see same thing for N15 and F19 also. For nitrogen, how many protons are there? 7. For fluorine, how many protons are there? 9. Right? How many neutrons are there? 15 minus 7 is 8. 19 minus 9 is 10, right? Now n minus p. N minus p is 8 minus 7, 1. N minus p for plural, 10 minus 9, 1. See, n minus p is exactly same. And such a species are called as isodiverse. Okay, that's how all these species are. Okay, sure. Next, isotones or isoneutronic species or isotonic. Now you all know iso means what? Iso means same or equal. Iso means same or equal. And neutronic, what is mean by neutronic? Having number of neutrons. So they are having same number of neutrons. You can predict that from their name itself. So they are the atoms of different element. They are the atoms of different element which have the same number of neutrons. Atoms of different element having the same number of neutrons. Okay. Let me give you an example for that. See, carbon, the different types of isomers of carbon is C14, 6, nitrogen 7, 15. Now, the number of neutrons for carbon are how many? 14 minus 6, 8. For nitrogen, 15 minus 7, 8. In fact, you can also take the oxygen here. Atomic number 8, mass number 16. 16 minus 8, 8. See, all these three species are isotones of each other because they are having same number of neutrons. So species having same number of neutrons are called as isotones. So moving ahead. Isostars. What is mean by isostars? See, they are the molecules which have same number of atoms and electrons. Oh, sorry. See, these are the completely different category now. What is mean by isostars? They are the molecules which have the same number of atoms and electrons. Look at this. How many atoms this species has? 1 carbon, 3 oxygen, 3 atoms, 2 nitrogen, 1 oxygen, 3 atoms. Number of electrons. What is the atomic number of carbon? 6. Atomic number for carbon is 6. How many electrons it should possess? 6. For oxygen, atomic number is 8. So it should possess how many electrons? It should possess 8 electrons, right? So 8 into 2, 16. 16 plus 6, 22 electrons. So this species contain overall 22 electrons. As far as N2O is concerned, each nitrogen contains 7 electrons because atomic number is 7. So 7 into 2 plus oxygen 8. 7 into 2, 14. 14 plus 8, 22. So it also contains 22. So such a species are called as isoters. Okay. Then CaO plus Kf. See, all of both these species contains 2 atoms. This also contains 2 atoms. This also contains 2 atoms. Okay. Now let's calculate the number of electrons. Atomic number for calcium is how much? 20. Right. So number of electrons it should contain is 20 only. For oxygen it's 8. So 20 plus 8 is 28 electrons. For potassium atomic number is 19. So number of electrons are also 19. Fluorine atomic number 9. So number of protons electron also 9. 19 plus 9, 28. See, so the species which contains same number of atoms and same number of electrons. CaO CO2 and 2. Such species are called as isostars. Okay. So, and lastly, isoelectronic species. What is mean by isoelectronic species? Now you can calculate that from the name itself. Iso means what? Same. Electronic means what? Electrons, right? So the species contains same number of electrons. Any species. They could be atoms, they could be molecules, they could be ions which have same number of electrons are called as isoelectronic species. For example, N3 minus, O2 minus, F1 minus, Na plus 1, Mg plus 2. All of these species contains number of electrons are 10, 10, 10, 10, 10. So all these species are what? These are nothing but the isolate. They are containing same number of electrons. Or you can go by this way also. NH3, H2O, HF. Number of electrons are 10, 10. So these are also isoelectronic species. The species containing same number of electrons basically are called as isoelectronic species. Okay, sure. Moving ahead. Let me give you one more example. Next example is quite interesting. H2SO4. If you calculate the number of electron H2SO4 has is hydrogen is having 2 electron, 2 into 1. Sulfur is having 32 and oxygen 16. Oh, sorry. I made a mistake. No, it is not. Sorry. It is not. Okay. I was actually calculating its atomic mass. Atomic mass is completely different thing. Okay. So that's it for the isoelectronic species. Moving ahead with this, let's solve some question based on that. See, if the mass of neutron is doubled and the mass of electron is half, then if the mass of neutron is doubled and the mass of electron is halved, then find out the atomic mass. Then the atomic mass of C612, the percentage by which it changes is how much? Oh, extremely sorry. So what that's saying is that if the mass of neutron is double and mass of electron is halved, then find out the atomic mass of C12 and the percent by which it increases. See, if you write C612, 12 is its atomic mass. Okay, and this atomic mass is also equal to mass number. And what is mean by mass number? Number of protons plus number of neutrons, right? It is equal to number of protons plus number of neutrons. Now you can see the atomic number is 6. So number of protons are 6 and number of neutrons are also 6. 6 plus 6 is 12, right? That is already given right in front of you. Now, what they're saying, if the mass of neutron is double, that means if you, it is like number of neutrons are 6. Okay, if you double their mass, it is as good as having 12 neutrons. It is as good as having 12 neutrons. And mass of electron is half. See, mass of electron is negligible. It's very negligible. So it doesn't matter even if you increase it tenfold, even if you half it, even if you double it, doesn't matter. So for the new species, now for the new species, number of neutrons are 12, right? Mass of neutron is double, so 12 neutrons are there. Now it is like that. And number of protons are still 6, right? Then the percent by which it increase. Now number 12 plus 6, which is p plus n. So 6 plus 12, now that is equal to 18. So for the new carbon, number of protons, which is equal to still 6, but number of mass number is 18 now, because you have double the mass of neutron. Okay, now, so what is the percent by which it increases? See, the percentage increase in mass should be how much? 18 minus 12, right? You have 18 minus 12. What was the original mass? 12 into 100. 18 minus 12, 6 by 12 into 100. 6 by 12 is how much? 0.5 into 100. That is equal to 50%. The percentage by which mass should increase is 50%. It increases by 50%. And that's how you can calculate the percentage by which mass can be increased. Okay, sure. Moving ahead. Next, if the mass of neutron is doubled, that was the next question. If the mass of neutron is doubled, and if the mass of proton is half, and the mass of electron is doubled. Now again, I had told you earlier, mass of electron double, triple, quadruple, half, doesn't matter. So you can simply ignore this. Then find out the change in atomic weight of carbon. Now atomic weight of carbon right now, 12 divided by 6, its atomic weight right now is how much? It's 12. Okay, now. And it has how many protons? Number of protons are right now 6. Number of neutrons are also 6. Okay. So, in a new species, what are they saying? Mass of neutron is double. That means 6 into 2. So mass of neutron is 12 now. You have a 12 neutron, and mass of proton is half, right? So 6 divided by 2 is equal to how much? Proton are 3. So doubling the mass of neutron is like taking double the number of neutron. It is as good as that. So I took 12 neutrons instead of 6, and proton mass is half. So I took 3 proton. Now P plus N gives you your mass number, and mass number gives you your atomic weight. So P plus N is how much? P plus N is 3 plus 12. That is equal to 15. And 15 should be the atomic mass. 15 should be the atomic mass of your new. Okay. That is how you can calculate the change in atomic mass. Okay. Moving ahead. So that's it for today's lecture. Actually, I was about to continue this lecture forward, but it seems that I'm not feeling really well. I'm having a cough, cold. Okay, so we'll stop here. In the next lecture, we will continue with the other part of structure of. We'll be taking it forward. Okay, we'll be taking it forward by considering the other concepts of structure of. Okay, for more such courses, please like, comment on this video. Please subscribe to Practically. You can also download the Practically app from Apple Store and Play Store. You can log into it. We have a very interesting courses in a Vedic maths, coding, chess, robotics. You will really enjoy it. Okay, that's it for today's session.